So I'm here to talk about validating CSV files. Typically, I tend to talk too much, and I have far too many slides. So I'm probably going to skip through some of the first ones fairly quickly, but they'll be online, so you can always go back and have a look at them. So, I'm a software engineer, and mostly I'm a database geek. I like to sort of hack on NoSQL databases, which typically means that you end up working with lots of data, which is good fun. And for the last couple of years, I've been having the most fun I could probably possibly have by doing some work for the National Archives in the UK. It's been absolutely fantastic. And while I was there, one of the tools that we developed was in the area of CSV validation, so we'll talk about that. So, this is National Archives. If you don't know it, it's a very nice place. You can go and visit there. It's open to the public. So I encourage you to go and have a look at the wonderful records that they have there. So what is the National Archives? Basically, it holds governmental and public interest public records from the UK. We try to ingest huge amounts of data into our archive. They're very good at holding paper records, and they have some history working with digital records, but the current system that they have really won't cope. We're predicting taking in about 6 petabytes of digital records in the next 6 years or so. So there's quite a lot of work there around digital records to think about. Something I should probably mention is there's 2 different types of digital record that typically we'll deal with. We put these into the classes of either born digital, which means that these records were not created on paper, they're originally created on machines, but they're still official government records. So these may be Microsoft Excel documents, PowerPoint, Word documents, emails, videos, almost any file format that you can possibly imagine. And we have to somehow process this information and make sense of it. So it's interesting. So how do we receive digital records? No, sorry, the other type of classification of records, digitalisation. So we won't digitise all paper records, but some paper records, there's a public interest or perhaps even commercial value in digitising these records and making them available online. So when we receive records, they come by all sorts of means, but often it's just a pallet full of boxes of hard drives that have been shipped to us by some government department. And we have no idea really what's on these hard drives. It might be, you know, literally they've been ripped out of computers, so they might be a C drive with Microsoft Windows and everything that's on there you can possibly imagine. And the idea is that somewhere in there are some governmental records, if we're lucky, and we have to know what these are. So assuming that we can work that out, we then need to load the records into our system. We need to test and secure them. So whilst obviously everyone tries to maintain a high level of sort of computer security, these are coming from central government, but they may have malware or viruses on them. You know, it's entirely possible these machines are in all sorts of states. So there's a certain amount of security that we do. We have to examine the records, we have to understand what they are. You know, how do we archive this thing? How do we search it in future? How do we present it to the public? And one of the ways that we do that is during the ingestification process, we have a lot of tools that will extract metadata from the records or infer metadata. That's not the only metadata that we have, and we'll get onto that in a bit more detail shortly. Obviously, once we have all this amazing information that we've put into our digital archive that we're kind of trying to keep for hundreds of years, we have to be able to retrieve it and search it and even perhaps update it. The idea that an archive is immutable, that's not necessarily the case. People want to be able to curate records and improve the information about them. And eventually we want to probably publish them either through commercial partners so we can make money to continue running the archives, or even publicly online on our own website. So there's a few, if you work in the archives or other sectors and you're interested in digital preservation, there's a few really interesting questions. The hardest one, and this kind of changes, is what actually constitutes a record. So what constitutes a governmental record that we're going to preserve? Is it a Microsoft Word document? Or is it the Microsoft Word document plus the timestamp from the file system? Or, you know, any other amount of information? And also, when you get shipped a disk that contains God knows what, how do you know what to take off that disk? You know, what is worth preserving for the nation's history and what is really just another copy of Microsoft Windows. And you really don't need to preserve that, right? So DRI is our new digital preservation system, and obviously we're given these disks and we have to give these to the system for which we've written the software. How does the software know what it's meant to take off of these disks, and how does it know how to make sense of it? I mean, these files are kind of everything and anything, and they all need to be processed slightly differently perhaps, or handled in different ways, or there's exceptions for this type of file or that type of file. How does the system know what to do? So the way we solve this is we've used lots of metadata. So as well as the metadata that we can extract and infer from the files during the ingestion process, we expect to have metadata supplied along with the files that are sent to us. So, and there's mixed success about that, which I'll talk about later. So we take different types of metadata. Technical metadata, so we have a disk of files. What are the checksums of the files? What are their timestamps? They didn't necessarily come from a file. They might have been exported from a document management system. You might have richer metadata. Who edited these files? When did they edit them? Who were they created by? Which department? This kind of information. We're also quite keen on provenance information, particularly around digitalisation. It's much harder to get in the born digital world because if I make a copy of the file, which is the record? I don't know, actually. It's very difficult. But when you do digitalisation, there's lots of information you can capture. Which scanners were used, by which manufacturers, who did that digitalisation, where did it happen, when did it happen, what were the settings they used in the software, how did they convert this image to this image? You know, lots and lots of technical kind of provenance information around images. Not to mention, you know, what was the source of the record? Where is the piece of paper? How do I go back to it? On top of that, if it's a digitalisation project, we're taking transcription information. This varies, as you can imagine, collection to collection. We have records about, I don't know, war diaries. There's a different sort of information that you're going to transcribe as opposed to a public inquiry about the sinking of a ship, perhaps. So there's lots and lots of different sorts of information there. And then on a sort of more businessy side, we have to understand what the closure of a record is. And for us, the closure means how long is the record closed for? So when you take records from government, they're not necessarily available to the public. Okay? They will eventually probably be public records, but typically the ones that are closed will be closed for 20, 30, or maybe even 100 years, depending on their sensitivity. And we have to hold those records and keep them away from the public during that time. And then, as soon as they're available, we can publish them. So record selection process, how do we know what we're receiving? We expect government departments to go through some sort of process and choose what they're sending us on these disks. As I've said, sometimes we just get hard disks full of everything. It's very hard to enforce this. There's no mandate for government departments to actually send us records, even though it's an expectation. There's no sort of legal standing for this. And then we're asking them to provide metadata. So will they provide the metadata? How difficult is it for them to provide metadata? Will they not provide metadata? Who knows? Well, actually, so. Okay, cool. So collecting metadata. So we have all this metadata we want to take. For digitalisation, it's easier because we say to a commercial supplier, digitise our records. This is the metadata that we want back. So we set standards for this. And even for the record selection process by government, when they send us records, we have much simpler standards. Okay, we want the title, we want the description of the record, we want the author, this kind of thing. The hardest thing was how we get that information. Most of our systems internally are a mix of XML and RDF, not XML RDF, let's be clear. That's the sort of information that we want to store and want to work with at a systems level. But we couldn't rationalise having suppliers or government departments provide us with this because simply they don't have the resources. Either they don't have the technology, or they don't have the training, or it's just too complicated, to be frank. So we settled on CSV as what we call the lowest common denominator. So everybody has, well, not everybody, but it's very likely that people have Microsoft Excel installed. They can double-click a CSV file, it opens up. This is an amazing piece of technology, everyone's very happy. They don't have to install anything. This is very key in government. A lot of government IT is outsourced. There's a huge cost with having to do something for the IT department. So, past experience. So, do government departments send us metadata? Mostly. Okay? what we found is if it's too difficult for them to do it, they won't do it. They'll just say, no, you can't have it, but here are the records. And then we have to figure it out. And that's difficult for us. So we have metadata problems. The metadata that we wanted to collect is quite complicated. There's lots of different types of this metadata: transcription, technical, provenance, closure. They all have slightly different requirements, even when they're expressed in CSV. The biggest mistakes we had initially were transcription. So we're saying, okay, please type in the dates in this format, so our system can process them. Okay, nice and simple. We'll use a UK date format. We're not asking for anything too complicated. People really get these things wrong. They miss key, or they're tired, or they don't understand. So there were lots of mistakes. And the best one was people would just rename Excel files. Oh, I want a CSV file, cool. Just rename it. Turns out, okay, what's this? So that was fun. And computer, oh god, yeah. So suppliers, they'll try to cut corners to save costs. It usually costs them more because we ask them to do it again. They don't learn. Microsoft Excel as well. You open a CSV file and it thinks this is a formula. It's not a formula, and then you save it, and then you end up with a mangled CSV file with like this hash name thing in it, where it screws up your dates, and you have to be a little bit careful. There's some training required. Okay, so I'm running out of time there. So what we learned was our system's built around taking in all this CSV data that we set standards for, and we were receiving this information from government departments or suppliers, and we're doing a big batch processing job, and it would fail. And then we're going, oh god, why has it failed? And going, oh look, they've miskeyed this one row out of 250,000 rows or something. And it was really painful process. So what we needed was some way to detect the errors in the CSV data as soon as possible, so that we could just fail really quickly and then get them to fix it, rather than sort of they send us this, we try to ingest it, it fails, we ship it back to them, say it's wrong, they say what's wrong, we say it's this. You wouldn't believe. It's complicated. So, how do we solve it? So we wanted to validate our CSV files. We already had the standards kind of set out on paper. We kind of knew what we were doing. So we built an internal tool, and this was for a proof of concept. So it was for something called the Home Guard, which is people that were left behind in the UK in the Second World War that sort of guarded the shores against invasion. So it's records about these people, and we built a tool to validate our three types of CSV files. In this case it was closure, provenance and transcription, and it worked pretty well. We managed to process 82,000 records, and our tool basically cross-checks against the images that we had digitized. Okay, so it will check some of the images and make sure that in the CSV file that checksums list is correct. Because people are copying these files around onto disk by hand as well, so sometimes they copy the wrong thing into the wrong folder. You need to know that that's okay. So it kind of worked. Excellent. And we were able to get quite good feedback about this, but the problem was we still had suppliers shipping us disks, and we were doing the checking, and then shipping it back and saying there was a problem. So after a bit of encouragement, we managed to convince the internal government departments it would be a good idea to share our code with our suppliers. Excellent. So now the suppliers are doing the checking, and we don't have to do. Well, we have a lot to do, but not that. So we got a little bit faster at this. Okay, so we've got a tool for doing CSV validation. It's great, but it's very hard coded to one data set, our proof of concept data set. So version 1 looks nice, but we want version 2. So people should be able to write their own rules. Okay? So I've got a CSV format. I want to validate it. I want to write my own rules for this. And it has to be written by domain experts, so archivists, not me, not programmers. I think I can still write them, but it's okay. So, and it has to be open source. I have to be able to share it with my suppliers. Yes, it has to be useful for lots of different things. So suppliers have to be able to use this as an application. It has to be a library that I can put inside my batch processing pipeline as well. It's going to be used in lots of different places. So we created a language, a grammar, for expressing CSV validation rules. It's pretty generic. It has lots of expressions and types. Most importantly, I think, it's expressed in plain text. So as an archivist, I don't have to understand JSON, I don't have to understand XML, I just need a text editor to write these rules. And we try to make them usable for humans. This is really important for the domain that I come from. I'll just go a bit fast because I'm running out of time, but I want to get into some examples. So I talked about some of the things. So plain text is very, very important. It's not a programming language. It tries to be sane by default. You know, this is designed for normal humans, not developers. Who are a strange breed. So here's a piece of CSV Schema. So here's my data, and this is my schema that's going to validate this data. Okay? So it's pretty simple. It's column-based. So rules are written per column. So on the left, I have 1, 2, 3 columns defined, and on the right of the column, I have some rules about what this has to do. Okay. So hopefully that's fairly straightforward. Everybody okay with this? Yeah. Okay, good. I'll talk in a bit more detail about that in a moment.
Well, what's our column missing?
So we've got first name, last name, gender, and date of birth. So, yeah, I've just got my data at the moment. Yes. So, this is a quality example, because when I run this piece of schema against my data, I'll get validation errors, and I can go back to my government department or my supplier and complain. So, well, who spotted that? Gold star. I'll talk to you later. So, another example. Obviously, CSV isn't always comma separated. It comes in lots of different formats. So we try to cope with this. So under the version line, the things that start with ats are what we call global directives. Thank you. And they change the processing of the entire process. Okay. So when I pass the CSV, it's now dollar separated. It's quoted. The total columns thing is optional. It just means it doesn't early check that there are actually 4 columns in the CSV file. No header. Obviously, not all CSV files have headers embedded in them, so you would want to start processing on line 1 or line 2, depending. And then there's some kind of nice, interesting things in here. So I can do like, you know, is it a feline or is it a canine? And you know, this string must be between 3 and 255 characters. But on a higher level, this one just has to be a positive integer. So we try to write quite high-level rules that you can compose together. So there's a slightly more complicated one here. So we do, in our data, we have if one column is this value, this column must be this. So this is sort of code variance kind of stuff. So the dollar here, the animal, that means, you know, if the value in the animal column is mouse, then the number must be between 0 and 3. Otherwise, it's just a positive integer. And the optional, so we have column directives as well. So if there is a value in this column, it must be between anything and 255 characters long. Otherwise, if it's not there, that's okay too. Cool, thank you. So I mentioned earlier that we had to do things against files, checksums, counts, are there 10 files in this folder, this kind of thing. So we have this concept of external expressions. At the moment, they're mostly around files. So in my CSV data, my checksum column has a MD5 checksum in it. So checksum is the name of the column, and then based on saying if the file name ends with a slash, well, I think that's a folder, so I would just assume that, you know, the checksum column is empty, you can't checksum a folder. Otherwise, I want to checksum this file, taken from the file name column, and the algorithm is MD5, and it will basically assert that the checksum of this file that computes is the same value that's in the CSV column. So you can do some quite complicated kind of cross-checking and external cross-checking. And there's about 60 expressions, so there's a bit more. So we have a language, we now need a tool to run it. So we built a tool to implement the language. It's open source again, you can go and download this. I'm running out of time, so I'm going to skip forward, but it's a library, it's a GUI application, it's a command line application, which does everything, honestly, and things that I haven't thought of yet. Future work, it's all open source. We're looking for collaborators. We've tried to document it as a standard in a kind of W3C-esque style, but we're not W3C. Special thanks to friends that have helped on this at the archives and outside of the archives, and I just want to show you very quickly. This one, so this is our, it's a bit off the screen, but this is our standard. We use the same template that W3C used to try and make us look official. So it's mostly sort of written between myself and the National Archives, but we would encourage other organisations to get involved. You know, we actively want people to think about this stuff and use it. Where does it fit with Jenny's work? A lot of this was done before the CSV web group started, so we can kind of tie this all up in one neat thing together. That would be even better. So, thank you very much.
Two questions, maybe?
Yeah, okay.
Do you have a ballpark figure for how many copies of Microsoft Windows are archived?
If I've done my job correctly, and there's no guarantee, then we shouldn't have archived any. Because at the National Archives we don't preserve software, and we take a stance, which is that we don't do emulation either. So our policy is to do format migration even when we need to do it. So, any other questions?
Or like for me, this validator for CSV file writing by hand is quite cumbersome, right? Especially when it's not like you told that you got around 60 functions for like expressions you should be using. Do you have any kind of generated for you or something?
We don't have any sort of IDE tool or plugin or kind of GUI for designing the schema language. I guess it does. I'd like to think that anybody can write it, and we do have archivists at the archives that are non-technical writing this. I won't say that it's easy for them. I think that would be unfair, but I think it's easier for them than trying to write XML or JSON or IDF. But yeah, if somebody wants to create some sort of GUI or tool for creating these things visually, that would be amazing.
How about an online validator?
Something like CSV Lit, perhaps. Yeah, so the reason there isn't one is because I wrote my presentation yesterday, and I didn't have time to create an online validator. But it's quite easy because there's a Java API and there's a Scala API. So if you know those, you can stick together a web page pretty quickly to do validation. So I hope to have one soon.
I just want to ask, how many schemas do you think are there? Like,
How many schemas?
yeah.
So I don't know of anybody, well actually I do know a couple of people outside of the archives that are using this. We have some example schemas on our GitHub. The ones that we share with our suppliers are on our GitHub. And internally we probably have about 20 different schemas at the moment, but every collection we take probably generates 3 or 4 more.
So just building on the automation question, is there any, this is for archival work, but is there anything when at the document creation level that you would put the metadata schema there so that this work in the future is a lot easier?
Sorry, I'm not sure I heard the first part of the question.
Just I was building on the automation question. Is there any work that the archives is doing with document creators so that this work is done on the front end now that documents are being created, that the metadata schema is being...
So we tend to create schemas up front and then give them to the government departments and then ask them to supply their metadata in that format, and then they can test it internally before they send it to us. But otherwise, no, I'm afraid.
Yeah, just, I guess policies, interesting.